G'day and welcome to BoringBlackBox. Here we have the BBB DBT version 1.0, a compact, current limiting dim bulb test device, an absolute must-have for any repair tech's workbench. As you can see, it's constructed using readily available, inexpensive yet safe components. On the rear of the unit, we have a 1.8 meter, 3-core, 1mm cross-section power cable. The ends have been stripped and tinned, ready for a qualified person to fit the power plug of your choice. At the top of the box, we have an E27 or Edison screw lamp holder. We have a fuse holder loaded with a 250 volt 6 amp fuse as standard. We have an input and fuse status indicator light. Over on the left hand side, we have our main power switch. On the right hand side, we have our limit and full selection switch. And on the front panel, we have an international style 3-pin power output socket. Okay, time for a demo. Out of shot, I have a 100 watt per channel power amplifier. I will now just plug that in. Like so. For this demo, I'm using a 100 watt standard filament Edison light bulb, although I do recommend using a much lower wattage for your tests, especially if the equipment is completely unknown. Have the DBT box connected to a quick test box here for power feed. I will now activate. And there we are. This is the standby status. You can see the input and fuse indicator light is on. It's shimmering in the video, but it's very solid in real life. Now we're ready to go. Power on. Lamp glows brightly, then dims right down, indicating no major faults. There's a click I hope you heard in the background. That's actually the speaker protection relay in the amplifier being activated. On a lower wattage bulb, due to the current restriction, that sometimes doesn't happen. It's not a problem, it's just the fact that you've got extra restriction on the current through a lower wattage bulb. If there was a problem with this particular amplifier, this bulb would still be shining very brightly, and in which case the power should immediately be switched off and the problem resolved. Now that we know that there are no dramas with the connected device, we can flick it over to full power. Doing so basically shorts the bulb and feeds full mains potential from the rear of the box through to the socket at the front and out to the device under test. As a little bit of a feature, both switches have a neon backlight, and that's a very convenient way of, at a glance, status of the box itself. We turn that off, the neon backlight switches off. Now that we've got it back in limit mode, of course, the bulb filament is softly glowing again. I'll now power that down completely. I'll move that out of the way as I have prepared another DBT box here. I've removed the screws so we can have a look inside. Not a lot to see in here. The inexpensive boxes are pretty solid, but they also feature some channels allowing you to mount them directly to another surface, i.e. a wall or a larger test board, or even directly to your workbench. It's quite a nice little feature. All the internal wiring is 1mm cross-section copper. The wires have been fed through the holes of the terminals on each component, folded over, carefully soldered, and then heat shrunk. You can obviously see quite a lot of black hot melt glue throughout the unit. Even though the components snugly fit into the cutouts I made, I've added the glue for extra strength and protection, especially over a longer term. One more thing to talk about in here, the earth wire in the input lead feeds directly to the earth pin on the output socket. Okay. Thanks for watching the video. I hope you enjoyed it, and goodbye for now.